Hi, my name is Greg Myers. I work in the Environmental Health and Safety Office here at Providence College, and one of the things I handle is I deal with lab safety. So today I'm just going to go over some basic lab safety concepts with you, and I'll start at the beginning, a little bit of background. OSHA and EPA have a lot of regulations that Providence College has to comply with in the lab. OSHA, as you may know, is the Occupational Safety and Health Administration. They deal with protecting human health in the workplace. EPA is the Environmental Protection Agency. They obviously deal with protecting the environment. And these regulations are applicable to what you'll be doing in the lab because you may be working with some materials that have the potential to harm either people or the environment if they're not handled properly. And that's the important thing to take away from this, is that if you implement a few safe lab working practices, working in the lab is no more hazardous to your health than washing the dishes at home or something along those lines. So I should also say at this point that inevitably somewhere along the way you're going to have questions, and when you do, I can't encourage you enough to go see your professor. They are professionals. They're there to help you. They've been doing this for a long time. They know how to work safely. And they know, we as the Environmental Health and Safety Office, we have a close working relationship with biology department, and that means that they know all these safety regulations that I'm talking about. They know all these regulations that they have to comply with, so it makes them a really valuable asset to go to if you have questions. And today, we're really just going to be covering basic lab safety. Once you get into your labs, your professors are going to be the ones to really flesh this material out and reinforce it. They're going to be the ones to assist you and really further your education, not only in an academic sense, but also in the sense that they'll be able to teach you better lab practices. So with that, the main OSHA requirement that we have to comply with is we have what's called a chemical hygiene plan. No matter where you go in the U.S., all labs are required to have a chemical hygiene plan under OSHA. And it really just guides how we operate in the lab. And that's great and all, but what does that mean? Well, in a broad sense, the chemical hygiene plan is part of an overall safety ethic that we have here at Providence College. And the key idea is to promote, one, that we learn about the hazards of the substances that we're working with. Two, we protect ourselves against those hazards. And three, we look out for each other. We keep each other accountable. The safety of the person next to you is just as important as your own safety. So that's what I mean when I'm talking about the safety ethic. And that's exactly what the chemical hygiene plan aims to accomplish. So how does it do that? Well, it establishes policies and procedures that aim to minimize the chance of an accident, and promote your health, and keep you safe and healthy. You guys, as students, actually have responsibilities under this plan. We have an entire program here dedicated to your safety. That's the #1 goal. And it really all falls apart if you don't take responsibility for your own safety as well as the others around you into your own hands and really internalize it. So first and foremost, obviously, is just work in a responsible, safe manner. Also, getting into a little bit more detail, when your professor tells you to do something a certain way, it's because they've been doing this for a long time and they know how to do this. They know how to work safely again. So really, I can't reinforce this enough. Listen to what they have to say. They're excellent guides to have. You also want to wear your protective clothing, your protective equipment. That means goggles and glasses. We'll talk about that a little bit later on. Follow established emergency procedures. If you have a spill, what do you do? If you have a fire, what do you do? Again, we'll talk about these later on too. Also, report any accidents or any spills that you have. If you get hurt, for one, we want to make sure that you get the medical attention that you need. But for another thing, we want to remedy any unsafe conditions that may have led to that accident in the first place. And also, even if you notice any unsafe conditions, it's important to remember that nothing's going to happen unless you bring it to somebody's attention. Even if you're not sure if something's safe or not, in this case, it's really better to be safe than sorry. I don't normally agree with this, but in this case, there's no such thing as a dumb question, especially when it comes to somebody's safety. Okay, and this leads us to an interesting statistic, and that is that schools, just like Providence College, have 10 to 50 times more accidents than what you find out there in the chemical industry. And the question is why does this happen? And I'm sure there are honestly a whole host of reasons why this happens. For one thing, you guys are college students. You may not get enough sleep the night before. You may be tired in the lab. And plus, in an undergraduate lab, there are generally a lot more people working. Research labs only have a few people working at any given time. Well, there's more chance for bumping into one another or not being aware of what the person next to you is doing, or just distraction in general, whether it's catching up on the daily gossip or checking out the hot guy or girl across the lab bench. This is life, and we know these things, but you just need to be aware of it in your head and be cognizant of what's going on around you, because there's that much more chance for an accident when there's a lot more people around. Probably the more likely reason, or at least I think, is that students are simply less experienced than professionals. It's just the way it is. You're going to be working with new equipment for the first time. You'll be doing new procedures for the first time. Again, when your professor is setting up this lab with you, they will tell you exactly how to do things, exactly how to use specific pieces of equipment. Really heed their instruction and pay special attention to what they have to say. And also, there's something to be said for having a certain healthy respect for chemicals. It was Mark Twain, actually, who said, "It's better to be safe 100 times than to get killed once." I tend to agree with the guy. And in fact, Dr. Toth, the current chair of the biology department, his own mother said they're called accidents for a reason. So again, take your time, think about what you're doing. All right, and with that, I want to get into some specifics about how chemicals can actually harm your body, because that's important to be aware of. And in a general sense, very broadly speaking, there are two ways that a chemical can hurt you. One is through their toxicity. We call these health hazards. And a toxic chemical basically disrupts the normal function of your body's cells in one way, shape, or form. There's also physical reactions or physical hazards. These things are more obvious to us, but they cause physical harm to our body, whether it's a burn or a rash or an irritation, things like that. And I'm going to talk about each of these. I'll start with toxicity because that's a little bit more involved. Now, there are 5 primary, what we call routes of entry, ways for toxic chemicals to get in your body. And the way that toxic chemicals work is once they get into your body through one of these 5 ways, they get into your bloodstream. And from there, they travel throughout your body to what we call various target organs, whether it's your kidney or your liver, or your spleen, your heart, your central nervous system, and your brain, whatever the case may be. Because different chemicals have different target organs, but they get into your bloodstream and then go to the target organ from there. And the 5 ways that they can get into your body is 1, through inhalation. You can breathe it in. They can be absorbed through your skin or through your eyes. Ingestion, we don't normally eat and drink lab chemicals, but there are other ways that I'll talk about in a minute for chemicals to get either on your face and eventually into your mouth. And the last one is called penetration, and that's when there's a direct breach in your skin or breakage, some sort of incision, and the chemical gets inserted directly into your bloodstream. You can think of needles and syringes as the primary example for that. All right, so specifically about inhalation. I'm sure all of you are at least moderately interested in biology, so I'm sure you can understand this. But what your lungs breathe in, they then try to take and distribute throughout your body. That's the way they work. They take in oxygen, put it in your bloodstream, and it goes throughout your body. Something to keep in mind, if you can smell a chemical, it means you're being exposed to it. Doesn't mean that everything's bad. I mean, mom's home cooking smells great. We hope, at least. And that's not bad for you at all. But there are some chemicals out there that don't have a smell to them. They don't have an odor. So you can't just rely on your nose alone to tell you if you're being exposed to something that you shouldn't. So you got to use your brain a little bit too. When you're working with any chemicals that have an inhalation hazard to them, you want to be working in the fume hood. That's what they're designed to do. They're designed to take those toxic vapors and carry them away from your breathing zone. In the Gen Bio lab that you'll be working in, there are only I think 2 chemicals that you'll be working with in the fume hood. So again, your professor will tell you what these chemicals are and explain how to use them in the hood at that time. All right, skin absorption. Again, we tend to think of the physical hazard associated with skin contact. That is, getting burned or getting a rash or an irritation. But some chemicals can actually be absorbed through your skin and get into your bloodstream that way. So it's something to be aware of when it comes to skin contact. It's not just the physical hazard that you need to worry about sometimes. And your eyes. This last bullet down at the bottom is probably the most telling, in that your eyes are very vascular. So anything that gets in your eyes can get absorbed into your bloodstream that much easier. Oftentimes we think of splashing, as that's the most obvious example. When you get something in your eyes, it hurts, Some less obvious examples, airborne dust. We don't often think of that, but if you're working with a fine powder and you're not careful with it, that dust can become airborne, can get into your eyes. You can also breathe it in, or it can get into your mouth. Vapors as well. You think of onions. Vapors can irritate your eyes just as well. So that's another way for chemicals to get in your body. Contact lenses, I'll say at this point, yes, you can wear them in the labs. They are allowed, although that's all the more reason to wear goggles. You don't want to get something in your eye when you're wearing contacts. If you wear normal prescription eyeglasses, they do make goggles that fit over them, and you do need them because they have that opening around the sides, so they don't really provide adequate protection for what you need in the lab. Okay, ingestion. As I said, normally we don't eat and drink this stuff. It's more of an accident most of the time. It's a matter of personal hygiene. The number one way to protect this is just to wear your gloves. When you're done, take them off, throw them away. You can wash your hands. And when you're in the lab, don't go touching your face or scratching an itch on your face. Find another way to take care of that. But that's another way for something to get from your gloves onto your face and into your mouth. As I said, it's a matter of personal hygiene. And the last route of entry, penetration, again, think of needles and syringes. Be careful where you put these things. Also, if you're working with a scalpel, as I said, there's normally a lot of people working around you in an undergrad lab. So don't put this stuff down right next to your partner. Put it somewhere safe. If you have broken glass, make sure that gets cleaned up right away. Also, if you have any cuts or scrapes on your skin, cover them up with a Band-Aid before you go into the lab. Pretty common sense stuff for the most part. All right, so that's a lot about toxicity. I'll talk briefly about some of the physical hazards of chemicals. Some chemicals are flammable. Some are reactive, namely oxidizers are the biggest concern. And some chemicals are corrosive. It's also important to note at this point that materials, they may be hazardous in more than one way. You can have a flammable material that's also toxic to your body. So just some things to think about. Real briefly, flammable chemicals, really obvious. Anything that can easily be ignited by a spark or a flame, or even a cigarette. It's a really subjective way of putting it, and there's actually a technical definition for